Okay, so this is a tutorial on functions and stacks in Mips assembly language. I'll cover details about functions, stacks, stack pointers, how to make them, which registers to use, and little quirks about each one of them so that you know what to do before you attempt to write your own program. I'll write a basic program and run through each line and how it works. So first let's start by making a new file. We go to new file. I'll save this as functions and tutorials. I like to add some comments at the top of each program just to let me know what the program does and what I made it for. For this one, I'm going to write something like tutorial by Ruvim about functions and stacks in Mips assembly language. Let's start off by making a .text section. We'll put our main header in there. I like to use this no op after every header and function. No op stands for null operation, and we use it because when you go to assemble the program, you can see the header along with all the other files you have to execute. See if I make two functions, one with a null operation and one without the null operation, and I switch over to this execute tab, the one with the null op will show up, and once I add a null op to the function 2, it shows up along with the comments on the same line. Anyways, let's get rid of these examples, and I'll add 4 strings under our data sections so we can use and print them out while I assemble the program and make it look pretty. I'll make and print this basic test string and end the program. Run it just to make sure everything is working. Now let's make our first function using the no op, the null operation. The way we make a function is by typing the function name followed by a colon. I write mine left justified to make the code neater. Before we call and use functions, you need to understand that the label of the function is just an address. Every line of code has an associated address that's stored in memory. In order to call a function, we have to jump to that address and start executing the code leading after that address. We want to specifically use the jump and link command when calling functions because when the other forms of the jump function, such as jump or jump register, are used, they do not save the address of the next command to execute after the program runs through the function. Back in our program, we use jump and link to jump to the function. I'll add some print statements inside our function and one after the function has been called. The jump and link command saves the address of the current program counter +4 inside the RA or return address register. Since each address is stored in one word, and since one word is 4 bytes, in Mips at least, to get the next address, we need to add 4 bytes. If we step through the program one line at a time, you can see the return address register change to the address of the next line to execute. You can verify what I'm saying by taking the current program counter, in our case the line where jump and link function is called, and add 4 to that value. The result should be the same number stored in the RA register after the jump and link command. Okay, so once our function finishes executing, we have to jump back to our main function to finish the rest of the program. We do this by using the jump register command, JR. This jumps to the address stored in the RA register. We can do this type of jump command because we do not need to save the address of the next line to execute. Let's run our program to see all this in action. First, we have our test string printed. Then we call our function. We print the line from function. Then we jump back to the main program. We print the second line and exit the program. Although this program works, it won't work when you have a function being called from inside another function. For example, let's say you have a program. In this program, main calls function 1, then function 2 gets called from inside function 1. After function 2 executes, we call jump register using the return address to get back into function 1. We finish running function 1 and jump register to get back into main. The problem is register RA stores the address of the line right after we called function 2. So if we call jump register RA, it will loop back to the middle of function 1, and this will repeat over and over until your program crashes. The solution is to use the stack. A stack is a data structure that holds values. It's commonly drawn like this and can be implemented to grow up or down. In Mips, the stack grows downward. The stack pointer register holds the word at the top of the stack. Remember, a word is 4 bytes of data in Mips. Every time a new piece of data is added to the stack pointer changes to that word. To load data to the stack, first increase the size of the stack. Up is considered positive and down is considered negative. Therefore, since Mips stack goes downward, we have to subtract the amount of words you want to increase the stack by. The second step is to load our data into the new stack position. To get data from the stack, load the info stored in the stack pointer into whatever register we need. In this case, it will be register RA. Then decrease stack size. thing to note is that elements in the stack that come after the stack pointer are considered invalid. We will use the stack to store our return address before we call the next function. Technically, you can save the return address at any time during the function, but I find it useful to push my return address into the stack as soon as I enter the function. To finish off the program, we need to push the return address to main into the stack at the start of function. Then we need to push the return address to function at the start of the inner function. I'll add a print statement inside the inner function for demonstration. Next, at the end of each function, we have to pop the stack to get the correct address to return to. When writing code, it's useful to keep track of what's in your stack so you know what to call when you need a certain piece of information. For one operation here, let's execute the program and walk through the output. Inside main, we print out the test string. Then jump in link to function. Inside function, we save the return address to main. Then we print out the function string. Jump and link to the inner function. Inside the inner function, we save the return address to function. Print out the inner string. Get the return address to function from the stack. Then we jump back to function and continue executing it. In function, we get the return address for main and jump back up to main. In main, we print test for the second time and finish off the tutorial by ending the program. One final note before I end the video. In Mips, the registers A0 through A3 are used to store arguments leading into functions, and the registers V0 and V1 are used to store the outputs from those functions. These special registers are not regulated by the Mips architecture, so it's up to the programmer to ensure proper use of the registers. It's important to use the registers with their intended purpose, even though you can use them for not their intended purpose, so that other programmers can interpret your code. More information about each of these registers can be found by Googling Mips register files.